Yeah, good morning, students. So, today we'll be going ahead with the other topics. Okay, so our topic of discussion today would be IC741. Okay, so I think in your DLP first semester DLP course in the lab, I think you have seen several ICs. Okay, I think you're exposed to several such ICs. I think you have checked all these ICs, NAND ICs, NOR ICs, all these XOR, XNOR, even NOT ICs, the hex NOT ICs also. I think you are aware, you have worked with such ICs. Okay, so even IC741 is a similar IC. So IC here stands for integrated circuit. Okay, so IC stands for integrated circuit. Okay, so IC741, okay, is one such IC. Okay, which is called an op amp. Okay, so IC741 is an op amp IC. Okay, so here op amp is shortcut for what is called as an operational amplifier. Okay, so op amp is short for operational amplifier. Okay, so like the name indicates, it is basically an amplifier. It tends to amplify the input voltage at the output. Okay, whatever is the input that you are applying, it is amplified and it is given at the output. Okay, so now let us look at the symbol of an op amp. Okay, so this is how an op amp symbol is drawn. Okay, it basically has two terminals. Okay, so one is the positive terminal. Okay, it is usually referred to as VP. The other is the negative terminal, which is referred to as VN, and this is the output terminal, Vout. Okay, so apart from these three terminals, okay, there are two other terminals. Okay, so these are nothing but the power supply terminals. One is the plus VCC and the other is minus VCC. Okay, so this is your op amp symbol. Okay, any generic op amp will have these terminals, will have one VP terminal. Okay, so this terminal is also called as non-inverting terminal, positive terminal or non-inverting terminal. Okay, and VN, okay, is also called as inverting terminal. Okay, so any op amp would have these inputs and outputs respectively. Okay, so Vout is where you collect the output, and plus VCC minus VCC is where you power the IC up. Okay, so it cannot work without powering it up. So this is nothing but the power supply. Okay, it has a dual power supply rail, that is you will be applying plus VCC and minus VCC. Okay, so this is where we see the pin diagram of IC741. Okay, so like I said, these basic pins will be there and some extra pins also would be there. Okay, now let us see the pin diagram. So it basically has 8 pins. IC741 has 8 pins. Okay, so you know how to start or how to number the pins. Okay, so you identify the notch over here, that becomes the pin 1. Okay, then you label the pins sequentially. Okay, once you hit the bottom, you take an U-turn and then start numbering sequentially again. Okay, so that is why 1 2 3 4, you take a U-turn, and then 5 6 7 and 8. Okay, so in this, okay, so let us try to identify the terminals that we have discussed here already. So pin number 2 is your inverting input, that is negative input. So this is pin number 2 on your IC. Okay, pin number 3 is your non-inverting input terminal. Okay, so this is pin number 3, and pin number 6 is your output. Okay, pin number 6 is your output. We have also discussed about V plus and V minus, plus VCC minus VCC. So pin number 7 is your plus VCC. Okay, and pin number 4 is your minus VCC. So pin number 4 is your minus VCC. So that leaves us with pin number 1, 5 and 8. Okay, so 1 and 5 are called offset null. Okay, 1 and 5 are offset null, so these are not used often. Okay, and their usage is out of the scope of this syllabus, so you did not worry about these two terminals 1 and 5. Okay, they are seldom used. Okay, and eighth one is NC, it is an extra pin. Okay, just to have the symmetry, we have this pin. Apart from that, it has no use. Okay, so eighth one is NC. NC stands for not connected or no connection. Okay, just to have a symmetric device, we have this extra pin. So that is the pin diagram of IC741. Okay, it is very important to remember. Okay, so one common mistake students do usually in the labs, in the practical sessions, is so they usually mess these two up. Okay, so they give positive power supply to the negative and negative to the positive. Okay, that burns the IC, so that proper care one needs to take. Okay, also people get confused between 2 and 3. Okay, so pin number 2 here is your inverting input, and pin number 3 is your non-inverting input. Okay, so if you can remember them, fine, but while you are working in labs, okay, you always need to have the data sheet and the pin diagram ready, okay, for quick reference before you are doing any experiment. Okay, right, so let's proceed. Okay, so let us now discuss what an ideal op amp characteristics would be like. Okay, so what an ideal op amp would be, and how close is our 741 op amp to those characteristics. Okay, so what are ideal op amp characteristics, we will discuss now. Okay, so an ideal op amp, there are many op amp characteristics, but our scope is very limited in this course, so I'll be discussing very few. Okay, so the first op amp ideal op amp characteristics that we require is infinite gain. Infinite, let me stand corrected, infinite open loop gain. Okay, so open loop gain is nothing but AOL. Okay, A subscript OL. Okay, and for an ideal op amp, we require an infinite open loop gain. Okay, so on an ideal op amp, we require infinite input impedance. Okay, infinite input impedance. Okay, and on an ideal op amp, we require zero output impedance. Okay, zero output impedance. Okay, right, so let us now try to understand the operation of an ideal op amp. So like I discussed earlier, this is the symbol of the op amp. Okay, so this is the plus symbol, this is the minus symbol. Okay, so and then this is V out. Okay, what is happening here is input impedance looking through these two terminals, that is Z in. Impedance is nothing but resistance. Okay, we haven't come across the terminology called impedance. Okay, but impedance, you can think of it as nothing but resistance. Okay, so I'll put R in here, input resistance. Okay, so R in looking through these terminals is infinity. Okay, so what that means is there would be no current flowing into the op amp. Okay, so that is what that means. Rin is equal to infinite input impedance means there would be no current flowing into the op amp, because when any impedance is any resistance is too high, we can treat it as an open circuit, and when there is an open circuit, we know that there is no current flow. So that is what is happening here. Okay, so infinite input impedance. Okay, infinite open loop gain. Okay, so this has a open loop gain of AOL, and that is infinity. Okay, so what is happening here is whatever what an op amp does is, okay, VP, suppose its positive terminal is VP, negative terminal is VN. What is V out is, V out is nothing but AOL times Vp minus Vn. Okay, so this is what your op amp does. Okay, so what an ideal on an ideal op amp, what we require is on an ideal op amp we require AOL to be infinity. Okay, so that means any small difference in these two terminals voltages, okay, it needs to be amplified infinite times. That is what this means. Okay, see what is happening, what is the behavior of op amp. V out is nothing but AOL times Vp minus Vn, where AOL is the open loop gain of this op amp. So what this equation means is any difference at the input terminals Vp minus Vn should be amplified infinite times. Okay, so that is nothing but V out is equal to AOL Vp minus Vn. Okay, and the third ideal characteristic that we desire on an op amp is nothing but zero output impedance. Okay, so zero output impedance, so there wouldn't be any impedance here. You can treat it as like I said, resistance. Okay, although we did not discuss the concept of impedance. Okay, so zero output resistance, that is nothing but any current that comes out of the op amp comes out in full. Okay, because there is no resistance over here, none of it gets dropped across any small resistance values. Okay, whatever is the current that is coming out of the op amp, it comes out in full. That means that is what people mean by having zero output resistance. Okay, but I say 741, but we live in a practical world. Okay, and of course you might be knowing that infinite loop, this doesn't make sense, right? Okay, so this anything in infinite, anything in such extremes are not possible practically. But let us look at how IC741, okay, how it actually performs, when compared to these ideal op amp characteristics. Okay, so let us now compare IC741 with ideal op amp characteristics. Okay, so this is the table that is giving you, okay, the comparison. Okay, so here I am talking about the open loop gain, the DC open loop gain, that is nothing but AOL. See, the ideal op amp has infinity, but the IC741, these are the figures of IC741. Okay, 100 dB is nothing but 10 power 5. Okay, although we do not have AOL as infinity, we cannot achieve that. Okay, but the practical value that we have to live with is AOL is 10 power 5 on your IC741. 10 power 5 is 1 lakh, which is pretty high, which is still very high. And see the input resistance. Okay, for the ideal op amp we discussed it as infinity. For the IC741 it is 2 mega ohm. Okay, mega is 10 power 6, again very high number. 2 into 10 power 6 ohm, which is a very high number again. Okay, and output impedance for an ideal op amp, we see it is 0 ohms. Okay, but an IC741 has output impedance or output resistance of 75 ohms. Okay, which is very less, see, when compared to something in mega ohms. Okay, and something is which is in tens of ohms, which is very less. Okay, so these are the some of the practical values that we live with. Okay, now let us see what happens with IC741. Okay, right, so this is what would be happening on an IC741 in open loop. Okay, right, so this is Vp, this is Vn. Okay, this is plus VCC, and this is minus VCC, and this is V out. Like we discussed earlier, what is V out on an op amp? V out is nothing but AOL times Vp minus Vn. Okay, so usually the VCC values for an IC741, if you look at the data sheet, okay, you can power it up. VCC can be anything between 5 to 15 volts. Okay, and according to the VCC that you apply, okay, the characteristics of the IC741 also change. Okay, so that is why it is called a linear IC. Okay, again we need not read too much into this term linear IC, but what a linear IC means is its power supply can be varied, that is it has a range. Okay, here IC741, it can be given, VCC can be given from 5 to 15 volts. Okay, and accordingly all the characteristics, the input and output characteristics scale accordingly, so that is why it is called a linear IC. Now back to our discussion. Okay, so usually this VCC is run at plus 15 volts and minus 15 volts. Okay, now what happens because AOL is a very high value, we have seen it in decibels. 100 decibels is nothing but 10 power 5. Okay, gain is nothing but a what do you say, a unitless value, that is why I'm not able to specify any units. Okay, so gain is output voltage by input voltage. Okay, it's because both the numerator and denominator are voltages, it doesn't have any units. Okay, suppose we have seen from the data sheet in the table above that AOL is 10 power 5. Okay, so uh, so let us see what happens practically. Okay, on an IC741. So this is 741. Okay, suppose I apply 3 volts to VP and 2 volts here at VN. What happens to V out is nothing but V out is equal to now 10 power 5 into 3 minus 2. Okay, so do we get 10 power 5 volts? This is ridiculously high voltage. Okay, we do not actually get it. Okay, but what happens is your IC741's performance is limited by its VCC. Okay, so the maximum output voltage that your IC741 can give is of course plus VCC, and the minimum output voltage your IC741 can give is of course minus VCC. Okay, so what happens here in IC741 is when your VP minus VN, okay, when your VP minus VN is positive, okay, that is your inverting terminal is at a higher potential compared to non-inverting terminal, then what happens is V out will be plus VCC. Okay, and when your VP minus VN is negative, when your VP minus VN is negative, what will be your V out? V out will be equal to minus VCC. Of course this cannot happen. Okay, output is 10 power 5 volts, it cannot happen because your IC itself is powered with 15 volts and your output cannot be greater than VCC. Okay, so that should make sense. Okay, so that is what happens in your IC741 when you are of course using it in open loop. Okay, so here there is the catch, if you are using it in open loop, what happens? So let us plot things here. Okay, so if your VP minus VN is a positive value, okay, so your V out, okay, so there will be, even for very small value, okay, even it is 0.1, what happens? 0.1 into V out is nothing but 0.1 into 10 power 5, this is nothing but 10 power 4. So even for small values, very small values also, you have plus VPN. So I can write something like this. Okay, plus VCC, and even for very small negative values, that is minus 0.0001 also, your output is your input is multiplied with 10 power 5. Remember, open loop gain is very high and it becomes a negative minus VCC. Okay, see, this is what the output does on a open loop IC741. This is how the output behaves on a open loop IC741. Okay, but that doesn't make any sense, right? We wanted an amplifier. Okay, so at least what I think an amplifier should be able to do is nothing but your output V out should be some k times your Vi. Okay, suppose you are designing an amplifier, okay, you would ideally want to be able to control it. Suppose you want to say to the op amp that my output should be twice that of input, or my output V0 should be 100 times of Vi, okay, or my output V0 should be some 30 times Vi, okay. So this is a good way of using an op amp. But here what is happening, a very small input voltage that is in the positive side, okay, is going to plus VCC, and a very negative and very small negative voltage at the input, that is when Vp minus Vn is negative, it is resulting in negative output minus VCC, okay. So if you want this type of behavior, okay, so that is if you want to be able to control the output, okay, so we need to understand a good, very important topic called negative feedback, okay. Only when we understand negative feedback, okay, then we can understand how such behaviors can be uh, designed from an actual IC741 op amp, okay. So that will be the discussion for our next lecture. Thank you.